Ngayon magsasagot naman tayo ng mga equations or functions involving exponential functions. So sa pag-solve at pag-graph ng mga exponential function, kailangan marunong na kayo mag-solve ng mga linear equations, ng mga quadratic equations, at marunong ka na rin dapat na mag-convert ng mga logarithms at mga exponential functions into a logarithmic functions at paggamit ng properties ng logarithms. So ito yung mga skills na kailangan natin para makapag-graph at makapag-solve ng mga exponential function. Now, by definition, ang exponential function daw na kung saan yung f of x ay equal sa a to the x, yung ating value ng a ay laging greater than 1 or different from 1. At ang una nating gagawin is to see the behavior of the graph of this function by graphing it using its general form na f of x equal to a to the x. Now, yung function na f of x equal to a to the x, lagi siyang may horizontal asymptote at y equal to 0 or dun mismo sa x-axis. Now, kapag i-graph natin yung exponential function of this form, lagi tayong merong y-intercept at 0, 1 at yung ating graph ng function ay laging increasing from left to the right of your xy plane. So ito yung general graph ng function na a to the x, na kung saan ang domain ng ating function will be all real numbers, which means negative infinity and positive infinity, at yung range of values naman natin would be from 0 up until the positive infinity. So ito ang behavior ng mga function or exponential function of the form a to the x. Now, kung bibigyan natin ng isang example yung ating function of this form, tulad ng f of x equal to 2 to the x, kapag nag-set tayo ng mga values of x at kukunin natin yung value ng f of x or yung value ng y, let's say negative 2, kapag ang negative 2 ay value ng x, magkakaroon tayo ng 2 raised to negative 2 at using the law of exponent, magiging positive siya kapag kinuha natin yung reciprocal niya. So magkakaroon tayo ng 1 all over 2 to the 4th or 2 to the second power, which is equal to 1 over 4. So yung value ng ating y ay equal to 1 over 4 or 0.25. Kaya ang ating coordinates at x equal to negative 2 ay negative 2 at saka 1/4. Kapag ang x value naman natin ay negative 1, so magkakaroon tayo ng function na 2 raised to negative 1, which is 1 over 2. So magkakaroon tayo ngayon ng coordinate na negative 1 at saka 1/2. So ito yung mga points na nakikita nyo, yan yung mga coordinates na nakukuha natin every time magsaset tayo ng value ng x. At kung ang x value natin ay 0, so 2 raised to 0 is equal to 1 kasi any number, no matter how big or small your number is, kapag ang exponent mo ay 0, ayon sa law of exponents, ito ay equal to 1. So ang ating coordinate would be 0 at saka 1. So ang ating coordinate or ang ating point would be at 0 and 1 at mapapansin nyo na yung ating graph ay nagiging kamukha na nung general graph na pinakita ko kanina. So kapag pinagpatuloy pa natin ito, let's say meron tayong positive 1, so 2 raised to 1 is positive 2, so meron tayong point at 1, 2, so ito yung point niya at kung dagdagan pa natin yung x coordinate natin ng positive 2, ang ating f of x would be 4 kasi 2 raised to the second power is 4. So ito ngayon yung ating coordinate for x equal to 2 at kung i-graph na natin yung ating function, makikita nyo na yung behavior ng ating function ay kaparehas ng ating general function a while ago. Dahil kahit anong value ang ating ilagay sa a, as long as it's greater than 1, ang ating function ay magkakaroon ng behavior na tulad ng graph na ito. Let's say instead of using f of x is equal to 2 raised to x, meron tayong f of x equal to 3 raised to x. So kapag ginamitan natin na siya ng solution at kinuha natin yung mga values of y given x at x equal to 0, meron tayong 1 at x equal to 1, 3 raised to 1 is 3 at x equal to negative 1 na kung saan meron tayong 3 to the negative 1 using the law of exponent, meron tayong 1 over 3 raised to the positive 1. So meron tayong 1 over 3. At kung positive 2 naman, meron tayong 9 at kung meron negative 2 would be 1 over 9. So ito yung ating mga values sa given values of x para sa f of x. At kapag nag-graph natin tong function na ito, tulad rin ng f of x equal to 2 to the x, parehas lang siya. So, ang behavior ng mga graph ng mga exponential function ay may pagkakaparehas. Ang pagkakaiba nga lang niya is kung magkakaroon tayo ng y-intercept na iba kaysa dito, kasi ang y-intercept ng ating f of x here is 0 and 1. Pagka naglagay tayo ng ibang y-intercept, it's either going up or going down lang siya. So, let's try naman yung ibang pattern ng function ng exponential function. Let's say yung ating f of x, instead of f of x equal to a to the positive x, meron tayong f of x equal to a to the negative x. So, mapapansin nyo na meron tayong negative exponent this time. So, titingnan natin kung ano ang kaibahan ng behavior kung ang exponent natin ay negative. So, kung i-graph natin yung nauna nating function na 2 to the x, ito yung graph ng exponential function natin. So, kung kukunin natin yung graph ng 2 raised to negative x, ito ay reflection lang along doon sa y-axis. So, ito rin yung magiging itsura ng mga function nyo kapag meron tayong negative exponent, tulad ng 2 to the negative x, or 2 to the negative or 7 to the negative x, or 8 to the negative x. Lagi kayong magkakaroon ng graph na tulad nito with a reflection on the y-axis. So, yung domain niya would still be all real numbers, at yung range natin will still remain as 0 and positive infinity. So, ito yung graph ng ating function na 2 to the negative x. At itong susunod naman nating function ay yung f of x equal to a to the x plus n. So, mapapansin nyo, meron na tayong constant na ina-add or isa-subtract doon sa ating function na a to the x. Na kapag meron na tayong constant na idadagdag sa ating function, tingnan natin kung ano ang pagkakaiba niya doon sa function na 2 to the x. So, yung 2 to the x, tulad ng mga naunang function, ito yung ating magiging reference graph. At ipapakita natin yung graph ng 2 raised to the x minus 1. Ang kaibahan ng graph ng 2 to the x minus 1 is that yung inyong function ay bababa doon sa y-axis. So, kung ang inyong y-intercept ay at 0 and positive 1, ang inyong y-intercept this time would be at 0, 0. At yung horizontal asymptote nyo ay bababa din at y equal to negative 1. So, bababa yung y-intercept, bababa yung horizontal asymptote, at bababa din yung inyong graph. So, ito yung magiging graph ng ating function na 2 to the x minus 1, na kung saan yung ating y-intercept would be at 0, 0, at yung ating domain will still remain. It will still be at negative infinity and positive infinity, or all real numbers, pero yung range natin magbabago na siya kasi bumaba nga yung ating graph. So, ang range natin would be from negative 1 to the positive infinity. At yan yung tatlong different behavior ng graph ng mga exponential functions, at mag-iiba-iba lang yung width ng ating graph, pero pare-parehas pa rin sila ng mga behavior. So, yan yung pag-graph ng ating exponential function. Now, let's go ahead and solve exponential function by using algebra. So, ang ating mga examples ng mga exponential functions ay tulad ng 7 raised to the 3x equal to 90, at saka 3 to the x equal to 5. So, mapapansin nyo na yung ating variable ay yung ating exponent. At kapag ganito yung ating equation, gagamitan natin siya ng mga techniques na kung saan isolve natin yung x using the properties of exponents at saka ng logarithms. So, ang una nating principle na gagamitin ay yung principle of exponential equality, na kung saan dapat yung ating a ay greater than 0 or positive number at hindi siya equal to 1. So, kapag meron daw tayong a to the x equal to a to the y, since yung ating a ay parehas at identical, pwede natin siyang i-cancel at magkakaroon tayo ng x equal to y, o yung mga exponents niya ay pwede nating i-equate sa isa't isa. So, ang example ng problem na ito, let's say meron tayong 5 raised to 2 to the x equal to 5 raised to the 7th. So, mapapansin nyo na yung ating a, which is yung 5, ay magkaparehas at identical. So, ang gagawin natin is pwede natin siyang tanggalin at pwede tayong magkaroon ng 2 plus x equal to 7. So ito yung paggamit ng principle of exponential equality. Now, let's say meron tayong 5 raised to x plus 2 equal to 125. Now, mapapansin nyo na yung ating 125 ay hindi kaparehas nung ating value ng a doon sa 5 raised to x plus 2. Pero alam nyo rin na yung 125 ay pwede nating i-modify by changing it into 5 raised to 3. Kasi ang 125 ay perfect cube, so pwede natin siyang i-modify into 5 raised to the third power para magkaroon tayo ng identical value ng a. And when that happens, alam natin na yung ating value ng a or yung ating index ay pwede natin i-cancel, leaving us with x plus 2 is equal to 3. So, since meron na lang tayong linear function, by solving for x, we'll have x equal to 1. So, ito yung isa sa mga examples ng pag-solve ng exponential function using the principle of exponential equality. Now, yung susunod na example natin, meron tayong 3 raised to x squared minus 5 equal to 81. Tulad nung ginawa natin kanina, mag-iisip tayo ng paraan para yung 81 ay magkaroon ng base na 3. At alam natin na yung 81 ay 3 raised to the 4th power. So, pwede natin i-modify yung 81 into 3 raised to the 4. So, ngayon, meron na tayong identical na value ng a ng ating exponential function na pwede natin i-cancel. Kaya, ang matitira na lang sa atin is x squared minus 5 is equal to 4. So, since natanggal na natin yung exponents, pwede na tayo mag-solve ng function or equation tulad ng quadratic or ng linear function. So ito, ang gagawin lang natin is to add 5 on both sides para matira si x squared equal to 9. At para matanggal naman natin yung exponent na 2, kailangan natin kunin yung square roots ng both sides. So when that happens, alam natin na yung 9 ay perfect square. So ang ating value ng x would be positive and negative 3. So ito yung isang version ng pag-solve ng exponential function using the principle of exponential equality. Now, meron din tayong tinatawag na principle of logarithmic equality na kung saan pwede natin gamitin yung logarithms para makuha natin yung solution ng ating exponential function. So, yung principle of logarithmic equality is kung meron daw tayong log of x to the base a at log of y to the base a, kung magkaparehas yung ating base, pwede nating makancel si logarithm at magkaroon tayo ng x equal to y. So, kung meron tayong log of 2x base 4 at log of 8 base 4, pwede nating cancelin yung logarithm natin kasi magkaparehas lang tayo ng base. So, ang matitira sa atin is 2x equal to 8 at masosolve na natin yung x by dividing by 2, so x is equal to 4. So ito yung pangalawang principle na gagamitin natin sa pag-solve ng exponential function. So kung meron tayong 2 raised to x minus 3 equal to 32, gagamitan natin siya ng principle of logarithmic equality, pero since magkaiba siya ng base, ang gagawin natin is isang technique na pwede nating gamitin para masolve yung logarithm using our calculator. So ang gagawin natin, since wala tayong nakikitang logarithm, mag-multiply tayo ng logarithms on both sides. At using the property of logarithm, mapapansin nyo na meron tayong exponent na x minus 3. Using the power rule, pwede natin siyang ibaba para ma-modify yung ating function at magkaroon tayo ng x minus 3 times log of 2 equals log of 32. So, since sinusolve natin si x at yung x minus 3 at log of 2 ay factors ng isa't isa, pwede natin siyang i-divide ng log of 2 yung both sides para makancel natin si log of 2 dun sa ating function. So, ang matitira na lang sa atin is x minus 3 equal to log of 32 all over log of 2. Now, in this particular case, hindi mo kakancelin yung log, but you will use a calculator para ma-evaluate yung value ng log of 32 at log of 2. At using the calculator, makikita nyo na yung ating log of 32 divided by log of 2 ay equal to 5. So, yung x minus 3 equal to 5 by adding 5 on both sides, adding 3 on both sides will give us 8. So, x is equal to 8. So, ito yung paggamit ng or pag-multiply ng logarithms para makuha natin yung solution ng ating exponential function. So kung meron tayong 3 to the x equal to 15, tulad ng ginawa natin kanina, imumultiply natin yung both sides by logarithm at using the property of logarithm or exponential property ng logarithm, pwede nating ibaba si x at magkakaroon tayo ng x log of 3 equals log of 15. So by canceling logarithm of 3 to the base 10, pwede nating i-divide yung both sides ng logarithm of 3 para magkaroon tayo ng log of 15 all over log of 3. Now, gamit ang calculator, ang value ng log of 15 divided by log of 3 ay equal to 2.4649. So ito yung value ng solution natin using the property of logarithm at ang ating calculator. So, sa last example natin, meron tayong 6 raised to 2x equal to 1,500 or 1,500. So, tulad ng ginawa natin kanina, mag-multiply tayo ng logarithm on both sides para maibaba natin si 2x at ma-divide natin yung both sides ng log of 6. And using our calculator, makukuha natin yung value ng function na ito by dividing both sides by 2. So, para matanggal natin si 2 by x, i-multiply natin yung both sides ng 1/2. So, meron tayong x equal to log of 1,500 all over 2 log of 6, and using our calculator, it will give us 2.0408. So, yan yung pagsagot ng exponential functions using the properties of logarithms. At kung meron kayo natutunan sa video na ito, please like, share, and subscribe to my channel. Thank you.